Good evening, and welcome to Cat Ninjas. Let's have another rocking night with geometry. So let's continue our discussion on triangles. I think in the last lecture we were speaking about triangles. Yeah. I think we were doing similarity of triangles. Then we ran out of time. So today we'll continue from where we stopped. In the sense, like we will try and explore the uh, right angle triangles. That's our agenda. In fact, we had for the last lecture as well, but since we couldn't touch much of it, we kind of winded up with one of the topics there, and we are going to continue. Good evening. I'm hoping that everybody is doing good. Warm welcome to the lecture. Yeah, before I get started, let me quickly introduce myself. So here I am. I'm Belvi Srinivas. So I've been working in the test prep industry for the last 14-15 years. That's since 2007. And I worked in various capacities, both as contributed towards management, the planning and decision making, and also towards the training of the students. Yeah, so during that course of those 14 years, I did develop some good skills to train and mentor the students, especially in the area of QA, DI, and LR. That's a little bit about me. Yeah, good evening, Keval. Good evening, Darshit. Yeah, okay. Yes, so if you are seeking the short interactions, so you can join this Telegram group or the notifications, or you want to ask something, this can be a channel through which you can communicate with me. And also there are quite a few active students out there discussing some of the important stuff, so they will also be kind of helping you each other, and that's how we can get a little bit of peer learning, etc. Okay, good evening, Chinmay. Good evening, Isha. Good evening, Preet. Join in. As you guys join in, let me just do quick announcements. So here we go. So there are some of the batches that are set to launch tomorrow. Especially if you are most of that you are following me, or from this particular lectures are meant for CAT 21, as most of you know. Yes, it is not that okay if you are preparing for CAT 22. I am not denying that you should not attend. It's not about that. But then yes, they are literally designed keeping CAT 21 in mind. So some of you may be taking NMAT as well. If you're looking at NMAT, probably this batch could be of some relevance and important to you. Yes, and there is CAT 22. There are certain batches launching for CAT 22. That's tomorrow. And also there is a batch which is already launched for CAT 22 on 27th. And this is going to be a weekend batch. There is one weekday batch and one weekend batch. Yeah. That's a little bit about the courses that are upcoming courses. And if you are preparing for CAT 21, maybe 6 months subscription could help you. Yeah, good evening, Nabia. Good evening, Vibha. Good evening. Yeah. Yeah, good evening, Lokesh. Yeah. Okay. Yeah. So if you are looking at CAT 21, so maybe 6 month subscription is one that you can look for, and you can try and take structured courses on SNAP, IIFT, ZAT, and a few other exams like TIS, and it could be MyCat, right? It could be TISNet or MyCat. That's for MICA. So some of these courses could be already there are structured courses you can do on these particular tests in the coming months or coming weeks. Yeah, and if you're looking at one-to-one interactions, if this is what you are kind of looking at, in addition to the structured courses, you might go for Iconic subscription, wherein you'll get the facility to interact with the mentors. How many meetings people, because sometimes you might not be aware how many meetings can technically be set up. You can set up somewhere about 25 meetings if you have a 6-month subscription, 50 meetings if you have annual subscription of iconic one. But there is an offer, so till 31st of this particular month, maybe next 2 days or so, instead of 25 you get 35 one-to-one interactions. You can plug one-to-one or 35 one-to-one interactions there. What do we do in the one-to-one interactions? You can set up either for your doubts, you can set up for your strategy discussion, you can set up for your study plan, you can set up for your form filling, application form filling of various B schools, you can set up for interviews, many other things. All right, you can set up to 35 interactions in about 6 months time. So you can discuss based on your needs, and you can set up with different mentors of your requirement. Yeah, that's a little bit about this. And then there are some offers going on till 31st of October. So if you get some time, take a look at these particular offers. These offers are with respect to buy a 3-month pack, you get additional 1 month. Things like that. On all the offers, whatever it is, if you on all these, you get 10% discount if you use any of the educator code, including my code, which is Belvi 100. Yeah, so that's a little bit about what the different subscriptions are. All right, so that brings us to the closure of of the announcements, and this sets up to get into the lecture. I guess in the last lecture, this is where we kind of stopped. One of you just kind of confirmed me. So I just left little thoughts about the right angle triangles. Yeah. You are non-engineering student. Ketan, you are asking that is BSc Maths and Engineering. How? It's non-engineering, right? BSc is a different course altogether. You are not counted under engineering. Why you get such doubts, Ketan? Okay, so here we go. All right, so this is what one of the things that we were kind of discussing with respect to right angle triangle. We were trying to mix up similar triangles with right angle triangles. I think this is where we kind of stopped. Rishav and Keval are kind of confirming on this. Good. Okay, what we do is we'll continue our journey. I will tell, maybe there are two important things I have to talk about the right angle triangles other than Pythagorean triplets, right? So I'm not really looking at the questions on Pythagorean triplets. We know that some of the important triplets are 3, 4, 5, 5 being the hypotenuse, that's one of the triplets. And then you know that 5, 12, 13, there are questions built on these particular triplets, and therefore you have 7, 24, 25. And then you have 8, 15, 17, then you have 12, 35, 37. Prominently, these are the 5 important triplets. What I meant by these triplets, of course, these are the basic triplets. We call them as 5 basic triplets. Are there many? Yeah, there are many, but then from CAT or any management entrance exam perspective, these 5 basic triplets are important. But will they be used in the basic form? Not necessarily. They need not be used in the basic form. They will attach k times. What do you mean by k? If I just take 3, 4, 5 as an example, and if I put k, and if I write k is equal to 1, put k is equal to 1, then it is 3, 4, 5. In the sense, what I'm trying to say here is, hey, they are 3k and 4k and 5k. Basic triplets are put k is equal to 1, you get 3, 4, 5. Put k is equal to 2, you get 6, 8, 10. Similarly, put k is equal to 3, you get this as 9, 12, 15. All these are Pythagorean triplets, right? All these are. So which means I can take one basic triplet and I can simulate many triplets. So in the exam, they need not necessarily use the basic triplet. They can use k value being changed. Okay, I'm not really prominently checking at this because I'm hoping that, okay, given down the triplets, we can work wonders. That should not be a problem. So let's look at, all right, now there's another important parameter on the right angle triangle. Let's take this example. This example will kind of illustrate, bring forth that particular point I would like to make at the beginning of the lecture. Okay, so let's get started. Keep your book, keep your pen, guys. Take your book, take your pen. No passive onlooking. If you want to do a passive onlooking, then you can drop from this meeting, right? Happily, you can drop from this meeting because that kind of learning doesn't make any sense. Keep a book, keep a pen, sit upright and start learning for the next 30 minutes, 40 minutes or 60 minutes, whatever it is, the time that we discuss. Okay, here comes, the diagram is given, the data is given, all of you try. So because of the cold start problem, okay, I will start by giving 2 minutes. Everybody start exploring on this question. It's a reinforcement. I expect that by now you are kind of know all these basics. Nevertheless, all right, let's reinforce our learning. Go ahead, everybody try, everybody keep book, pen and try. Yeah, it's a little difficult to plug the answers. I removed the answer options intentionally. Otherwise, simply people give A, B, C, D kind of. Doesn't matter. Okay, I removed it. Typing can be challenging. Even if you don't want to type, that's not a worry. Get it for yourself. That's good enough. Let's understand what is the underlying concept. Okay, all right, listen. So I wanted to just talk about 2 points here. Listen, everybody listen, that's okay, good time. So if I give a little more time, you guys will crack it. This is the problem of the cold start. When we do the first question, even in the exam, we will have this cold start problem. That's a reality. We may have to warm up a little bit. Okay, so I was just trying to remind you about two things. Had you just gotten those two things, you would have cracked it faster. What are the two things I'm talking about? Hey, we know that the side opposite 45, 45, 90 degrees, it's a right angle isosceles triangle. The side opposite these angles are in the ratio 1:1 root 2. Hey, this is very important facet because your whole of heights and distances is simply built on this. Very often 9 out of 10 questions on heights and distances is built on two premises. 9 out of 10. You don't have to use tan theta at all. Tan theta we will use if the angle become 15 degrees or 75 degrees. As long as they are 45 degrees, 60 degrees, 30 degrees, we don't have to, because we already know this by now. For sides opposite 45, 45, 90 would be in the ratio 1:1 root 2. Okay, if you are not getting it, let me draw quickly there. So let's say that hey, this is 45 degrees, this is 45 degrees and 90 degree. The sides opposite, if side opposite 45 is 1 unit, side opposite this 45 is 1 unit, then the side opposite this 90 degree would be root 2 units. There is another important proposition. What if it is a 30, 60, 90 triangle? Because I don't know, more often than not, either in the exams they use Pythagorean triplets, or they use 45, 45, 90 triangle, or they use 30, 60, 90 triangle. Whenever it's a right angle triangle, take a look at all the questions from 1992 onwards from CAT or ZAT or whatever the questions papers that are available. You find that 75% of the time, that is 3 out of 4 times, this is what is generally going to be used. Why? I don't know. All right, they want to keep it simple, but whether we notice it or not, it's up to us. Okay, coming to this, a 30, 60, 90 triangle, the sides opposite, look at the word, sides opposite these angles are in the ratio 1:root 3:2, right? Sides opposite. If I were to quickly explain this, might look something like this. Okay, this is 30 degrees here. So this is 30, say this is 60, and this is 90. Side opposite 30, I'm talking about this. Say if this is 1 unit, the side opposite 60 would be root 3 units. The side opposite 90 would be 2 units. Now this question uses both these propositions, because in one question I just wanted to cover both of them kind of and finished off, right? Yeah, so these are the two things I wanted you to understand. Had you just noticed that this fact, it takes about a minute to resolve this question, maybe calculation minute and a half or so. Fair enough. Let's take a look at this. Hey guys, this box is clear. This box is clear. This box is clear. I don't think it doesn't require more explanation than what I said. This box is clear. Quick. Why don't you guys put it in the chat? This box is clear. Yeah, the data in the box is clear. Can you confirm? Yeah, quick guys. Hey, not just Keval, Chandni, Vibha, others. Is it lagging? Yeah. Good. Nazia, Chinmay, Isha, Dia, Rishav. Not clear? You're wondering about the proof? Kishan is good. Srishti is good. All right. Yeah. Fantastic. Brilliant. Okay. So here we go. All right. Now this is what we were kind of talking about here. Okay, yeah, let's take a look at this. Hey, where is this man? I'll let know. So you find this isosceles right angle triangle. What is that? ADE. I'm coming here. Okay, this is an isosceles right angle triangle. So I will mark it like this. Isosceles right angle triangle. Author only said that. All right, it is right angled at D. Therefore, D I am marking it as 90 degree. Now, where is the question of isosceles coming? These two sides are equal. Fair enough. If these two, these two sides are equal. Yeah. Okay. So these two sides are equal means angle opposite this particular side is 45 degrees, angle opposite this particular side is 45 degrees. Therefore, I am saying that hey, ADE is what I am referring to 45. This is this one, ADE, I am writing it here. ADE is what I am referring to 45, 45, 90 triangle. The side should be in the ratio 1:root 2. Fair enough. All right. So now I know the area. Let's say that hey, this side is X. Therefore, this side, whatever it is, 1:1 means what? This side is X, this side is X, this side will become root 2 times of X. This hypotenuse becomes root 2 times of X. What is the area of this triangle? Area of the triangle is half, base is X, the height is X. Here, the base is X and the height is X, which is also nothing but, hey, which is also nothing but 2 centimeters square. That's 2. Therefore, X is equal to 2 units. All you are trying to say is, okay, I got it. This side is 2 units. This side is also 2 units. All right. These two sides are 2 units. If I were to to understand this hypotenuse, it will become 2 root 2 units. Nevertheless, all right, that's a point out there. Okay, let's keep that as it is. But what is that I'm interested in? I'm interested in the area of the larger triangle. That is what I'm kind of interested in. Good, let's come to it. Let's come back to that. Let's understand this. Let's multiple ways to go, but let me prominently use this 30-60 kind of caption. Now listen to me carefully. Focus on this triangle. Everybody quickly focus on this triangle. When I focus on also given that this is 75. What is 75? This particular angle is given to me as 75. Okay, if this is 75, this is 45, then I can find out what is this particular angle, which becomes 60. Very nice. If this is 60 and there is a right angle triangle here, therefore I'm quickly getting a 30-60-90 triangle. Fair enough. The side opposite 30 is 2 units. Therefore, side opposite 60 is going to be 2 root 3 units. Guys, did you reach this 2 root 3? Did we reach this 2 root 3? The side CD, all right, now this particular gap is 2 root 3. So looking at this hash triangle, looking at this triangle, did we get that 30, 60, 90? Therefore, did we quickly write this as side opposite 30 is 2? Therefore, side opposite 60 is 2 root 3. That's clear there? What is that? Angle DCE would be 30 degrees. Angle DCE would be 30 degrees. Okay, Nazia, angle, yeah, DEC. Yeah, angle DEC is 60 degrees, right? Angle DEC is 60 degrees. You want me to explain that, or you got it? Because there is an angle 75 given. AEB is equal to 75. Use that. Use that. AEB is equal to 75. Use this. And we know this is 45, and therefore the remaining is 60, right? Straight line angle. Yeah. All right. So now we got this. Now listen to me. Okay. Now let me erase this data. So we are done with this. We are done with this kind of data. Therefore, what is the complete length of this? The complete length of this is 2 times of root 3 plus 1. 2 times of root 3 plus 1. That is the complete length. What did I do? I added these two circles. One portion is 2, the other portion is 2 root 3. When I put them together, what does it become? This becomes 2 times of root 3 plus 1. That's what it becomes. Hey, what is this angle? Now look at this. Look at this. I'm marking in red, putting a star. This is 30 degree. That does not change. There is 190 degree, and hence I know that this whole triangle is, this whole angle A is 60 degrees. So therefore I have outer triangle ABC whose solid, now whose angles are 30, 60, 90. Okay, what is the angle opposite 90? 2 times of root 3 plus 1. That is 2 corresponds to 2 times of root 3 plus 1. Fair enough. Therefore, what does 1 corresponds to? 1 corresponds to root 3 plus 1. What is that? Side opposite 30. I can write this as root 3 plus 1. Okay, therefore side opposite 30 becomes root 3 plus 1. Okay, now what about 60 then? Root 3 times of root 3 plus 1. Okay, therefore you are saying that, hey, this entire base is nothing but root 3 times of root 3 plus 1. Now can I find the area of this triangle? Yeah, why not? Half base into height. Half. What is the base here? Base is root 3 times of root 3 plus 1. This is the base. Hey, what is the height of this? The height is another root 3 plus 1. That is the height. Okay, square this particular function. You get this half of, that is 3 plus 1. That is 4 plus 2 root 3 times of another root 3. Common, take common here. Therefore, you get 2 plus root 3 times of root 3. Simplify this. It will become 3 plus 2 root 3. This is the area. This is the answer. Simplification later, that should not be a problem there. Area of the triangle is half base into height. Upon simplification, you will get this as 3 plus 2 root 3. All right, everybody clear on this? How do we use 30, 60, 90 triangles? Basically, it's an illustration of importance of 45, 45, 90 and 30, 60, 90 triangles. Keep your mind open to this. That's very important. All good? All good? Any doubts, anyone? Yeah, Preet, you can make a note. Use tan theta and make a note and remember. Yeah. What is the configuration we are using? A divided by sin A is equal to B divided by sin B, which is equal to C divided by sin C is equal to, all these things are equal. Sine rule. Use sine rule, you will get whatever the angles that you want. Right? Okay. Cool. All right. Let's go to the next one. Let's go to the next one. Crack this. Now everybody crack this. Draw the figure. I will give good 2 minutes. Whatever the progress you can make in the 2 minutes, please make that progress. Everybody make this progress. Guys, all these are CAT replica questions. In fact, some of them are CAT questions. I just removed the answer choices to enable our learning. Enable our learning. Yeah, sometimes it is nice to learn without choices. That's what I believe in. That's good for revision as well. Because anyway, choices will not help you to arrive. For these questions, even if I give the choices, you will not be able to make a decision. Go ahead, draw the schematic diagram. Okay. All right. Fine, good. All right. Yeah. Let's take a look. Let's take a look. Let's do this together. Let's do this together, because if I keep giving you, I know that I give a little more time, you will be able to close something like that. But the point is, if I keep giving that little more time, then we will not progress. Therefore, I have to just take a it's a hard call. I know that some of you may be wanting, hey, just give us little time, we will close it, kind of. I know, but then somewhere I have to just cut it off and bring back the discussion, because idea here is not just I wait for all of you to finish. That's not. I give appropriate reflection time, think about it, and then we will do this. Okay, let's come back to this question. It's a right angled triangle where AC is equal to 8. It's given. All right, now AC, all right, now because it's right angled at B. If I put a schematic diagram, it looks like this. Okay, this is a right angled at B. Therefore, naturally AC is hypotenuse, because B is right angled at B. Therefore, AC becomes hypotenuse. Author is saying that length of hypotenuse is 8 units. Okay, and one of the angles is 30 degrees. Good, this is 30 degrees, and hence I know that, hey, the other one is a 60 degree. So very encouraging factor. The sides are, therefore angles of this triangle are 30, 60, 90. The sides opposite to them are in the ratio 1 is to root 3 is to 2. All right, this would be the sides opposite of this. Okay, but 2 corresponds to 8. It's given. A 2 corresponds to 8. If 2 corresponds to 8, 1 corresponds to 4, and this corresponds to 4 root 3. All right, so now this is what I kind of have. Then what is the length of BI? The question he is asking is, what is the length of BI? BI is nothing but this particular diagonal. All right, this particular line. All right, what if you want to understand the BI? This particular line becomes the BI that I am kind of looking at. Okay, there are multiple ways to proceed from here. Once you get this particular factor, you can proceed in multiple ways. You want to get the in radius, etc., etc. One of the easier ways, I will, because I am reserving certain discussion for the next questions, coming up questions. There are multiple ways to do from here. I'm reserving something because I want to first unleash this 30, 60, 90 kind of. Therefore, I'm reserving some thoughts. All right, you may say that, sir, I did like this. I know you might have done a little differently there, but I'm reserving them because I'm going to bring that issue in some time. After some time, I can bring that issue here also, but then the trade secret will go off. Okay, therefore, let's say, hey, let's stick to this 30, 60 kind of way. What I know, area is equal to, therefore you say that, okay, on this particular case, you say that area is equal to R into S. All right. So therefore, I will say that I will go R. What is the area here? Half base into height. I'm substituting half. What is the base? 4 units. What is the height? 4 root 3 units. Say here, 4 is on one side, 4 root 3 on the other side. Where is 4 root 3? Yeah. This whole stuff is 4 root 3. Where is 4? This whole thing is 4. All right, this whole thing is 4. Therefore, half base into height is equal to in radius into semi-perimeter. I'm adding all these numbers, that is 4 plus a 4 root 3 plus 8 divided by 2, something like this. Okay, you don't have to write as much as detail I'm writing. You could run a lot of mental math there. Some numbers can be added in your mind before you present it. Good, it appears something like this. Therefore, you say that, hey, from here also you can take up the 12 plus. All right, therefore you write this as r into 4 can be taken common. Therefore, you say that 3 plus root 3 inside the bracket. Here you have 4 times of 4 root 3. 4 and 4 cancelled. 4 and 4 cancel. And hence you say that, man, all right, radius in radius is nothing but 4 root 3 divided by 3 plus root 3. This is in radius. You may wonder why on earth you are finding in radius when the question is asking something else. Yeah, because this is in radius. This not this line. All right, when I draw this particular line, I understand that, hey, this is nothing but in radius. This is in radius out here. This is in radius. This is also in radius. If this is in radius, that is EI is in radius. Naturally, BD is also in radius. And hence I can get the length of BI. Author is interested therefore in what is the length of BI. BI, this is the 45, 45, 90 triangle. This is 45, this is 45. Why 45? Because two sides are equal. Two sides are in radius, equivalent of R. Therefore, that I just want the hypotenuse. All right, therefore answer is R root 2. R root 2 is the answer. Do I know the value of R? Yes, you know the value of R. Multiply this by root 2, which becomes your answer, and simplification is up to you, whichever way that you want to simplify. Simplify in that particular fashion, which becomes your answer. Technically speaking, 4 root 6 divided by 3 plus root 3. Maybe sometimes in the exam they might have already in the exam they might have simplified, rationalized the denominator. Rationalize the denominator, you get the question there. All right, did you get this point? Everybody clear on this? Everybody clear on this? This is the answer technically. 4 root 6 divided by 3 plus root 3. In the exam, generally they might have rationalized the denominator. Please do that. If they would have rationalized, rationalize it. Okay, all good? All good? Yeah. No, Keval, we'll come to it. What you wrote is wrong. We will see that. Okay, Nazia, all right. Right. We will come to that. Yeah, Keval, that's right. Yeah, that's right. That's also right. We'll come to that. We'll come to that in a while. There was a beautiful cat question built on that as well. We will come to that. That's when we will see. Okay. Yeah, this is clear. For now, this question is clear. Question is clear, because after finding in radius you get 45, 45, 90 triangle. Again, two things we are using. We started with 30, 60, 90 triangle, then we have to come to 45, 45, 90 triangle. This is what the CAT applications are technically. That is how beautifully they use these two propositions. They beautifully use these two propositions. Guys, are you all learning something? Basically, I'm talking about how do we use 30, 60, 90 and 45, 45, 90. Both examples had this element. That's what I'm talking about. Did you notice this? Both the examples from CAT had this element coming up, which is very, very important. It should be always on the top of your mind. 30, 60, 90, 45, 45, 90. Whenever you're looking at the right angle triangle, this should be at the top of your mind. I'm not promising that in every question this is what we use. Idea is, hey, this should never slip out of your mind. Alright, this should never slip out of your mind. That's important. Okay, good. All right, so crack this now. Having understood this, quickly crack this question, everyone. Crack it. Chinmay, angle bisector will not give. Because you may apply angle bisector, then what do you do from there? That's a question. From there, what you will do? Okay, that may not be useful here. Yeah, take a minute, think about this. I'll give a little more if required. Draw the diagram carefully first. Okay, I will give a little more time. I will count by myself some 30 seconds so that if you have put the diagram by now, you will have an advantage. Okay, great. All right, let's do this together. Let's do this together from here. So otherwise we'll simply run out of time. One of the schematic diagram can be this. This can be one of the schematic diagrams, right? So it's given that, hey, angle, listen, all of you listen, angle B is 90 degree. Then a perpendicular is dropped from the midpoint of one of the legs. All right, now these are the two legs. All right, this is one leg, or you may say that this is another leg. One of the legs, which leg? Choice is yours. Which leg? Choice is yours. I just took this particular leg. On this leg, the midpoint, midpoint. Midpoints means this length is same as this length. Draw a perpendicular. You may say that, no sir, I will not draw there. I will draw it here. I will take the midpoint of this. Okay, so let me complete this thought first. Okay, you took the midpoint on side AB. You took midpoint on side AB and you have drawn the perpendicular. If you do this, allocate the numbers properly. You say that then therefore this is 6 there and this is 10. Don't write, hey, this is 10 and this is 6, right? That would be stupidity. So you should understand that, hey, no, this has to be 6 and this has to be 10. So because we understand that where that longer edge is coming. Or you may say that, no sir, I will not draw on this. I will take a midpoint on this and draw. No problem. Drop a midpoint. Call this point as M. So the midpoint there. And from here you drop a perpendicular. From here you drop a perpendicular. Then you call this side as 6 and this entire length as 10. Something like that. So from where to do it, the choice is purely yours. There is absolutely no problem. Whichever side that you want, you can do that. That's absolutely your choice. Your answer remains same. Because once you draw, when you are drawing this, you might get this doubt. From where I should draw? The author, therefore, he said that your answer won't change. Therefore, he said one of the legs. Which leg? Choice is yours. Take any leg and proceed. That is the whole point author is trying to make. Fair enough. So now having understood that, let's now quickly take a look at this particular question. Okay, this is 90. So first let me go to the larger triangle. So let me call this as theta. Let me call this as theta dash. Let me call this as theta dash. What did I do? I named the angles of triangle ABC, saying that theta 90 degrees and theta dash. Okay. So now there is another one here is 90 degrees. Therefore, naturally this is theta dash. Good. I have a right angle triangle. At the same time, I have two similar triangles as well. Which are the two similar triangles? This triangle is similar to the larger triangle. These two triangles are similar. What all dimensions I know? I know the dimension here. This is 6. And this is 10. In other words, the complete length is nothing but 16 units here. This whole length is nothing but 16 units. Also, I know that, hey, I can call this side as x. Therefore, this side also becomes x. And hence, I know that the total length of this particular side is 2x. Now, take a look at the larger triangle ABC. Now, write the sides opposite the angles that you know. You know the angle opposite theta dash, and the sides opposite theta dash and 90. What all you know? You know side opposite theta dash. Okay. Side opposite theta dash is what? 2x. All right. Side opposite 90, do I know? Yes. Side opposite 90, you know, which is nothing but 16. Fair enough. That is done. So second one, all right. Therefore, from here, let's move to the smaller triangle. Let's identify the smaller triangle. Do I know side opposite theta dash? Yes, you know that is 6. Okay. Record it. That's I'm recording it for the triangle AMD. Do you know the side opposite 90? Yes, you know, which is nothing but x. They should be proportional. Why? Because these two are similar triangles. This by this should be equal to this by this. and hence you say that x square is x is, let me write x directly. Therefore x is equal to 4 root 3. X is equal to 4 root 3. Good. If x is equal to 4 root 3, come back to the larger triangle, my friends. Quickly come back to the larger triangle. See, this is where the points trigger, provided certain things are on the top of your mind. Hey, you have 16 here. So, and you have this whole length is 2 times of x. X is 4 root 3. Therefore, you write this as 8 root 3. The moment you see these two values in your mind, one is 16, the other one is this, you immediately get this as 8. You may say half, because you have 30, 60, 90. You are constantly thinking about the usage of 30, 60, 90, usage of 45, 45, 95. This is there at the backdrop of your mind. It is never out of your mind. So you know that the sides are in the ratio 1 is to root 3 is to 2. Okay. So therefore 2 corresponds to 16. Therefore you know that 1 should correspond to 8. Root 3 should correspond to 8 root 3. Given these two stimulus, which are the two stimulus, 16 and 8 root 3, you happily settle with this particular side being 8. Therefore what are the three sides? 8 is one of the sides, 8 root 3 and 16. The shortest side therefore is nothing but 8. So you apply this reverse also at times. You apply this reverse also. Given two sides, you kind of, it triggers your point and quickly you arrive at the third side as well. This can be applied forward, backward, whichever way that comes in the point. But the thing is, if it is on the top of your mind, you can do all this gymnastic. If the thought is not at the top of your mind, then again from here you do little bit more calculation. You use the Pythagorean theorem. Hey, I got this side, I got this particular side. You apply the Pythagorean theorem to realize that it is going to be 8. Okay, did it make sense to you? Forward, backward, both sides made sense. In this question, we applied 30, 60, 90 backward. Given the sides, we kind of already now recognize the angles of the triangle. And then we applied, we figured the sides. Clear about this, everyone? Clear about this? So given two sides, we concluded the triangle to be 30, 60, 90. Thereby, we arrived at the value of the third side. That's what the decision that we took out here. MD is not perpendicular to AB. It is given. It is given. See here. Okay. Keval. Let's now look at this. The perpendicular is dropped from the midpoint of. Listen, guys. Okay. Keval, you specifically you listen to the statement. Look, what is the language being used? A perpendicular is dropped from the midpoint of one of the legs. Perpendicular is drop onto what? To the hypotenuse. Perpendicular is drop onto the hypotenuse. Hypotenuse. Got it? Language is clear, right? Dropped on what? Perpendicular to what? To perpendicular to what? Perpendicular to hypotenuse. Language, long sentence, that's it. But follow the grammar. Perpendicular to what? Perpendicular to hypotenuse. Clear? Yeah, that's it. So use, it's a long sentence. That's what happens in the long sentence. GMAT is all about that, right? Why people do miserably on the GMAT English. Long sentences. One sentence will run some 3 lines. By the time they go there, they forget which phrase is doing what out here and they will make a mess up. Therefore, GMAT grammar is the toughest. GMAT grammar is technically considered as toughest in this entrance space, whole of the entrance space. Reason being, GMAT RCs are fine, GMAT CR is fine, GMAT grammar is considered toughest because you got to find an error in a line, in a sentence which is spreading across 3 lines. That makes it difficult. Yeah, nevertheless, that's all right. So we are anyway not writing GMAT here. Yeah, I understood, Keval. I understood. You made a language error. All right, good. Let's go on to the next one. So here it comes. Let's move on to the next one. You may think that, sir, you are given hexagon. Where are the triangles? Triangles are nothing but hexagons only. Right? Regular hexagon. All of we understand this. Therefore, nothing but triangular study itself. Yeah, go ahead. This should be answered in 1 minute. All those who did 11th standard or up to 10th standard. This can be answered in 1 minute, especially those who did 11th math. 1 minute you should give me the answer. Rishabh, that's a different issue. Don't worry. That we'll take it offline. Okay, all right. Okay, most usual method. Listen, guys, listen. Otherwise, we'll simply run out of time. Listen here. So, most usual method on this particular question could be something like this. Hey, this is, let's say that, hey, length of this is 2x, total is 2x. I will take the length of the complete side as 2x. Listen, everybody. I will take it as 2x. Out of this, you may say that, hey, therefore, this is x. Let me give some name here. Let me call this as ABC. Okay, so I will say that, hey, this particular portion therefore is x and this particular portion is therefore x, and it's also nothing but isosceles triangle because these two sides are equal. It is also nothing but I'm doing it in a little tedious manner. Listen to this where it comes. All right, so let's say that, hey, this is isosceles triangle and we all know that this angle is 120 degree. Interior angle of a regular hexagon is 120. Can I take it for granted? Interior angle of a regular hexagon is 120. Is that okay? Or should I explain that? Quick. Interior angle, each of the interior angles of a regular hexagon is 120 degrees. Correct? Yes or no? Yes or no? Yeah. No further explanation required. Say yes, no, guys. Okay, granted. Yeah, done. All right, everybody comfortable on that? Yeah, because you should, otherwise that itself is a stumbling block where you got this 120 kind of, right? Okay, that is clear. All right, now we can use this one property quickly. Let me revise this property. Hey, if I have any isosceles triangle for that matter, let me just take let's take this as an isosceles triangle. Okay, if I take an isosceles triangle, which two sides are equal? These two sides are equal. If I drop a perpendicular from the point A, say ABC is an isosceles triangle in which AB is equal to AC. If I drop a perpendicular onto the third side, now it does three things, all the things. I'm just revising everything in one shot here, right? So what all it does, it bisects this particular angle. If I drop a perpendicular, what all perpendicular does, it bisects the angle A, number one function. It bisects the base, number two, that's the second function. It bisects the base as well. It also leads to two congruent triangles, these two congruent triangles, all these things, all right, all these things. Therefore this line is also called as the median. This is the median. This is the perpendicular bisector of the side. This is also a perpendicular bisector of the side. This line is also the angle bisector. Three things. This line does three things. One, it acts like a median. It is the perpendicular bisector of the side BC. It is also the angle bisector of angle A. This line is doing multiple functions, and this line is also nothing but the altitude drawn onto the other side. A one line, many functions. That's a beauty of isosceles triangle. Any isosceles triangle for that matter. Okay, nevertheless, I made my point. So if I consider that particular factor, so I could say that, hey, I will drop a perpendicular here onto this. I will drop a perpendicular onto BC. If I drop a perpendicular onto BC, now let me draw the diagram. Let it appear like what I'm trying to draw. Looks like 120 degrees now here. Okay, so let me highlight it. This is where my A is, this is where my B is, C is. Now I'm dropping a perpendicular. I knew that the angle A was 120 degrees. Therefore, this is 60 degree, this is 30 degree, and this is 90 degree, right? Because this becomes 60. Why? Because this whole thing was 120 degrees. This entire thing was 120 degrees. 120 degrees, when I dropped a perpendicular bisector, it bisects that particular angle. Therefore, it has become 60, this. Okay, let me call this point as M. Now I have a beautiful 30, 60, 90 triangle. I have a beautiful 30, 60, 90 triangle. What do I know out of this? I know this. Hey, this was X. The length of line AC was X here. The point A is here, AC is here. What is this? X. Great. All right, side opposite 90 is X. Therefore, side opposite 30 would become X by 2. Side opposite 60 would become X by 2 times of root 3. X by 2 times of root 3. All right, out of this, what do I need here? I need the side opposite 60. Okay, side opposite 60 is X by 2 times of root 3. If this is X by 2 times of root 3, what is this? This is also another X by 2 times of root 3. Together, therefore, what is this? Together, this is nothing but X root 3 or root 3 times of X. This is together. And then you are saying that, okay, if the side of the larger one is 2X, listen carefully here. If the side of the outer one is 2X, the side of the outer one is 2X, outer one side is, this is outer one is 2X, then the side of the inner hexagon becomes root 3 times of X. Now what is the ratio of the sides? Ratio of the sides is root 3 by 2. Therefore, what is the ratio of the area? Similar, right? Similar, just like a similar triangles, we have similar hexagons. You may wonder from where you are getting similar hexagons. Both are regular hexagons, aren't they similar? If both have regular hexagons, they are similar. The sizes can be different, shape remains same. Therefore, it is not just the similar triangle, there can be similar quadrilateral quadrilaterals, there can be similar pentagons, there can be similar hexagons. The concept of similar can be put everywhere. Okay, therefore the sides of the similar hexagons are in the ratio 3:2. Therefore the areas will be in the ratio 3/4, which is your answer. This is all your answer is, because that's all author wanted. Fraction of the area of the outer regular hexagon is the area of the inner hexagon. That is inner hexagon in the numerator, outer hexagon in the denominator. What does it form? You are saying that that's in the form of 3:4. Comfortable? Everybody comfortable on this thought? Give a quick confirmation. I went roundabout by I explained that, hey, even if I knew 30, 60, 90, I would have passed on this particular question. Might have taken 2 minutes. Might have taken as well 2 minutes, but we could have done this. Clear? Clear? Everybody clear? Yeah, the beauty of 30, 60, 90 triangles appears like a hexagon question in CAT. Appears like a hexagon question in CAT, but ultimately it boils down to 30, 60, 90 triangle. Yeah, half the people, more than half the people leave this question because, man, hexagon, what do I do with this? Hexagon is given, leave it, man. This is not our cup of tea. Yeah, right. Fraction part is what? Hey, percentage question, man. This is the percentage question. What percentage? Forget this fraction. All right, convert this to percentage. Isha, convert this to percentage. What percentage of the area of the outer hexagon is the area of the inner hexagon? In the denominator, what should come? Outer hexagon should come in the denominator. What should come in the numerator? Inner hexagon. If it is a percentage, inner divided by outer into 100. So the percentage question. Right, percentage question, right? That's a percentage question. Fraction, remove this 100. If it is a fraction, percentage not required, right? Percentage, language, percentage question. Same questions can be asked as a percentage as well. Okay, now listen, everybody listen here. Okay, this is one way. Now, why did I say, hey, those who have done 11th standard, you will be much more familiar with the trigonometry. Of course, along with trigonometry, one more concept of geometry you should know, which is very, very handy. So, okay, I didn't speak about this in any of the classes. Therefore, I thought that hey, I must mention this. Otherwise, people will take this for granted. This revision is very, very important there. Now, take a look at this particular triangle. Hey, we anyway know this was an isosceles triangle. Triangle ABC was an isosceles triangle. Okay, let me redraw that, just highlighting it because that appears a little smaller there. Okay, so this was ABC here. So all that remains same. From here till here it is 2x, man. Okay, no problem. Therefore this is x and this is x. All right, AB is x and BC is x, and I know this particular angle is 120 degree, bringing forward 120 degree. Since these two sides are equal, the angle opposite both those sides will be equal, and hence it is going to be 30. Can I say that therefore it is a 30 30 120 triangle? Of course, yes. So now what do I know? I know that, hey, in any triangle, let me use that property quickly there. Let us use this particular property. Let's say that hey, I have just some triangle I have a triangle called as ABC. Okay, so now let me use this particular angle as x, let me use this as y, let me use this as z, let me use the side opposite of this is p, and say this is q and this is r. Okay, what do I know? Sine rule. What does the sine rule says? Sine rule says that p divided by sine x, P divided by sine of the angle opposite that will also be equal to Q divided by sine of the angle opposite of this here, Q divided by sine of the angle opposite this, Q divided by sine Y, which will also be equal to R divided by sine of the angle opposite of this side, R divided by sine Z. All of this will be equal to 2 times the circumradius of the triangle. I don't need this. At least if I understand this is the sine rule. Alright, in case if you want to find the circumradius, sure, I can use this. There is absolutely no problem. You want to complete this thought, it looks like this. But in this question, this was enough. Hey, the thought of sine rule was enough for me. This thought had come. I would have closed this question in 20 seconds, 30 seconds. I would have closed this particular question. Okay, guys, box is clear. Sine rule, the box is clear. Now don't ask me to prove all that. Sine rule, you should know. Sine rule, high school. Sine rule, the box is clear. Confirm, quickly confirm. Correct, right? Sine rule is clear. What I explained is clear. Summary. I'm explaining the summary. My point is when I say box is clear means what? Summary is clear. Yeah. What you said I could recall. That's all. That's all I meant. Okay. What you said we could kind of recall. Now don't ask me to prove and all that. We'll not have so much time. Right? Yeah. That's the thing. Proofs refer to Google. Google Mata will tell the answer. Yeah. She will give the proofs. Okay, great. All right. So here we go. Fine. So having understood this, apply this, man. Having understood this, apply this in the sine rule. Okay, what do you mean by apply? You want this, right? What is y? You want y, right? So y in terms of x. Basically, you want to write this y also in terms of x because you have one value in terms of x. You want the other value y also. Y should be written in terms of x. Fair enough. So what do I know? Y divided by sine 20, sine of 120. Y divided by sine of 120 is equal to, take one of the sides, whichever side you want, right, is also equal to x divided by sine 30. Do I know the value of sine 120? We know that sine 180 minus 60, nothing but sine 60. I don't think I have to write that. Sine 60 is nothing but root 3 divided by 2, which is also equal to x. What is sine 30? 1 by 2. Therefore, you say that, man, y is equal to root 3 times of x. Okay, therefore, this is simply root 3 times of x. Job over. This is for doing this already. You did lot of construction there, so just that, hey, use sine rule, you got the value as root 3x. all right, therefore the side of the inner side of the inner regular hexagon is root 3 times of x, side of the outer hexagon is 2 times of x. This is what you had the side ratio, area 3 divided by 4. Comfortable? That's all the effort you would have taken, which means just look at the diagram, you would have got the answer in 30 seconds after reading the question, of course. Just that if the sine rule would have clicked in your mind. It is important. My point is what? Don't ignore sine rule. In the previous class, I spoke about cosine rule. I can show many examples, but the point is, hey, I'm just trying to give the revision. It's not that I do 4, 5, 6, 7 questions kind of. Yeah. Okay. Right. Good. Yep. All right. Yeah, that revises about the sine rule as well, or otherwise 30, 60, 90 at least. 30, 60, 90 at least. Yeah, here comes a beautiful question. Because most of you already answered this question some time back. Please answer this now. Most of you actually answered a part of this question some time back. Beautiful cat question. Answer this. Yeah. What happened, guys? You actually answered it. Okay, listen, everybody listen. So area is 30, perimeter is also 30, right? Area is 30, perimeter is also 30, perimeter is also 30. Okay, how do I connect these two parameters? All right, A is equal to R into S. What is S? Semi-perimeter. Okay, what is area? 30. What is circa? What is in radius? R. What is semi-perimeter? Semi-perimeter is 30 divided by 2, because I know the perimeter is also 30. All right. Therefore, R is equal to 2. Okay, R is equal to 2. That is what we got. What is R? R means if I draw a circle here, the in radius of this. The in radius of this will turn out to be 2. Good enough. So therefore, from here you also know that he is asking that, hey, why don't you tell me about the hypotenuse? Some of you answered this some time back. You said that, hey, R can also be written as semi-perimeter minus hypotenuse is also equal to R. Semi-perimeter minus hypotenuse is also equal to R. The same information some of you guys have gave something like this. Hey, if this side is X, if this side is Y, and this side is called as hypotenuse, you say that I can also write this as X plus Y minus hypotenuse by 2 is equal to R. Now I am saying that, hey, add another hypotenuse here, add, and let me call hypotenuse as H. Let me call the hypotenuse as H. Add and subtract H. I can write this also like this. 2H divided by 2 is equal to R. From here you say that, hey, what is X plus Y plus R? Say, that's nothing but perimeter. Perimeter minus 2H divided by 2 is equal to R. Perimeter by 2 minus H is also equal to R. What is perimeter by 2? Perimeter by 2 is nothing but semi-perimeter. Therefore, semi-perimeter minus hypotenuse is equal to R. From whatever the fact we knew, we know all of we learned this in the high school. From whatever the facts we know, this is true only in the right angle triangle, right? This is true only in the right angle triangle. So in a right angle triangle, this works true, and it is very important. All right, it's very important. From this perspective, I can also remember this, or I can rewrite this. I can rewrite this. Even had I known this, I can extend this in my mind, and I can kind of rewrite this. From here, I will come to it. Hey, what is semi-perimeter? We know that it is 15. 30 minus 2. What is hypotenuse? Don't know. That's what I'm trying to find out. Hey, what is the in radius? I got that in radius is equal to 2. Therefore, what is hypotenuse? Hypotenuse is equal to 13 units. That is the answer there. Hypotenuse is equal to 13 units. Okay. So if hypotenuse is equal to 13 units, why don't you guys put this now in the chart? What is the circumradius? What is the circumradius of this triangle? Put it in the chat quick. 5 seconds. What is the circumradius of this? 5 seconds, put the answer. Circumradius. Very good. Yeah, perfect, perfect. Circumradius is half of hypotenuse, right? In a right angle triangle, circumradius lies on the midpoint of the hypotenuse. Very, very good. So therefore, you say that answer here is 13 by 2. 13 by 2. That is, in a right angle triangle, circumradius is nothing but hypotenuse divided by 2. Very good. All right, perfect. Done. Okay. Did you all understand this particular question? This is one of the very beautiful CAT questions, the first portion. It's one of the really beautiful CAT questions. The way they presented it was wonderful. Yeah, it's all very simple things. It is not that we don't know about this. We all know A is equal to RS. Who doesn't know about this? We all know this particular circle as well. We all know this. But the point is, we need to call it now. These things should come into the top of our mind, and we should start applying it. Right? It should come to the top of our mind. 4 or 5 thoughts would be there at our mind. Try and check what works better and start applying it. Guys, are you all learning something, making sense what I'm discussing? Yes, no? Are you guys all learning something? I mean, good reinforcement is happening. I'm not still bringing the circles. I'll bring the circles tomorrow. Yeah. Yeah. Yeah, Keval, don't worry. It's a matter of practice. Yeah, matter of practice. So when I also started looking at them long time back, decades back, I had the exact same feeling as you, right? Exact same feeling as you, thinking that if I just crack it, this is enough, man, forget it, kind of, right? And then we'll start seeing the beauty after some time. With practice, it comes. Don't worry. You will also find that beauty. Don't worry, right? Yeah, the journey is always tedious. Once you climb that summit, you will start enjoying the beauty, right? At times, like, you just have to climb the summit, but when you are climbing, it is painful. But when you look from there, it is beautiful. It's a matter of time. You also climbed there, right? So it looks like I climbed it. It's a matter of time that each one of you will be climbing there. You are in the process of climbing, therefore it appears like that, right? It appears like that. Good. That's nice. That's nice. As long as you guys are learning, that's very, very good. So here comes another question. Another question. Yeah. Yeah, Preet, I agree with you. Take a minute quickly, friends. Answer this. Shouldn't take much time. All right, let's take a look at this. Listen, guys, listen. What it's one of the important properties. Why I'm talking about this is one of the important properties. Of course, there is a right angle triangle here. This is a right angle triangle, no doubt. See, try talking to triplets. I was talking about it. I will not do too many questions on triplet because I'm hoping that you know those 5, 6 basic triplets which are technically used in most of our questions, right? So therefore, you might know that ladder slipping, all that stuff, those kind of questions which are technically make use of the Pythagorean triplets, no doubt. So that's what kind of we are trying to use. But what is the concept here? Once I know this is a right angle triangle, this actually makes this question little easier. That's it. Without that also we can find, but then I need further data on that. If I say that hey, ABC is this particular triangle, say this is 12 units and this is 35 units, and therefore hypotenuse is 37 units. In the beginning of the class I wrote this. What is the point I'm talking about? Shortest median is drawn onto the longest side. Shortest median is drawn onto the longest side. In the sense, if I wanted the shortest median here, pick the midpoint of the longest side and join this. This is the length of the shortest median, which is 37 divided by 2. That is the length of the shortest median that can be drawn in this. Shortest median is drawn onto the longest side. You want to understand this better? Think about this. If you want to understand this better, take this diagram, think about this. Hey, say, let now assume that this is an isosceles triangle. Assume this is an isosceles triangle. Of course, this is going to be the shortest median. This is the shortest median, midpoint, right? This is the shortest median. Shortest median, in fact, is drawn onto the longest side. It is drawn onto the longest side. Hey, where will be the longest median? Longest median will be drawn onto the shortest side. We said isosceles, therefore it doesn't matter. This would be longer than the median that you have drawn earlier. So that's a point there. Okay, I just helped you to visualize so that you kind of never forget this. Okay, shortest median is drawn onto the longest side, and the longest median is always drawn onto the shortest side. So that's what I was asking here. Therefore, I just wanted you to understand that, hey man, 12 is the shortest side. Draw this right angle triangle, pick the midpoint, call that as M, pick the midpoint, call it as M. Now you know that this is 6 units, this is 6 units. Join this, it becomes another right angle triangle. This becomes another right angle triangle. You just have to find the length of the median. AM is what you got to find. You know this is 35, you know this is 6. Therefore, you understand that AM is equal to under root of 35 square, which is nothing but 1225 and 36 plus 36 added together. So this is technically the answer. Therefore, you say that AM is equal to under root of 1261. Are you all clear about this? This was the concept I wanted you to recall for sure. One of the very important concepts from triangles on the medians. Making sense? Everyone clear? Yeah, therefore I said that 1 minute question. Why 1 minute question? If this concept is clear, how long it will take to write these numbers? It hardly takes any time to put these numbers to perspective. Right? Yeah, that's right, Rishabh. That is true. Yep. Yeah, very simple questions they ask sometimes. Because it's a right angle triangle. For them, it's a right angle triangle. They can make a non-right angle triangle and trouble us. Generally, they don't do. Yeah. Okay. Good. All right. So we will look at maybe another one. So you take this as a homework. You take this question as a homework. Yeah, you guys can take it as a homework and try to work it out. Find the length of CP. Please draw the diagram and then try to work it out. Maybe I will take this particular question tomorrow. All right, by now you are equipped to handle this. By now you should have been equipped to handle this. We'll do this. Tomorrow when I do the circles, if somebody has a doubt on this, then I will take this up during the circles time. Yeah, some of you might be having certain doubts, etc. Guys, use this particular platform, Ask a Doubt platform. Hey, before we do that, did you all learn something today? Was that useful revision that we did? Yeah, Rishabh, just look at those strategies, write the tests. You will not bother by speed breakers. Learn to jump speed breakers. Yeah, useful revision. Good. Karthik says very useful. All right. Yeah, nice. So in the sense, what I'm asking is, are we going on the right track? That's it, with respect to revisions. That's it. Right. So what should we modulate? From that perspective, I asked this question so that we can modulate the things and we continue to learn. That's the whole idea. It shouldn't happen that, okay, we are kind of not getting too much benefited kind of. That's the whole idea there, right? So whatever it is, yeah. Good. All right. Fantastic. As long as you guys are learning. Good. Okay, guys, if you have any doubts, please use this platform. That's a new feature. That's a new feature on your app. So you can use this particular feature, and it's a doubt. Basically, ask a doubt. And I think the limit should be within 1 day. You should be getting this. Yeah. Yeah, that's right, Rishabh. Can't help. Yeah, let's not worry about it. Yeah. So, and use this particular feature, screen grab, or just kind of like, click the picture. It's a self-explanatory. Please go through that. And I think you get the answer within 24 hours or something like that. All right, that would be it. That would be the thing. You can use this feature. So for your doubts, etc. But maybe all right, it would be definitely helpful in this last month to come. Yes, so those who are kind of little bit free. Hey guys, I did one small video about 30 or 40 minutes video. Watch it, what you should be doing in the last 30 days. In case you have not watched that particular video, I encourage you, just it's a short video, right? Kind of watch this. It'll give an idea about what I am expecting you guys should be doing in the last month or so. So make sure that on 31st, you already on every Sunday you write a test, and if you are free during this particular slot and you would like to take this particular test, take it. And there are a lot of analysis being thrown on some of these free tests. That's up to you guys can kind of look at this, and wherever already, if anybody is new here and you would like to go register, you can use this link to kind of register to that. Yeah, that pretty much brings us to the closure of this. As I told you, we will meet tomorrow at 10 p.m. We will meet tomorrow at 10 p.m. and I think tomorrow we'll start the circles. We'll start circles. So then we will be able to move all over, because we're not done anything on the curves. We are only doing on the straight lines, majorly with the triangles. Yes, we'll introduce curves tomorrow, basically introducing the curves. Once we introduce the curves on the lines, we can already play all over the ground, right? These are the two facets in the geometry. Okay, so if you have liked this particular video, like before you leave, put this as the like, and then you can leave there, right? Yeah, so you can subscribe to this particular the Cat Ninja so that you get this. You'll do that. Yeah. What are the slots? Keval is saying that first slot. Okay, Rishabh 12:30. All right. Okay, good night guys. Those who are leaving, good night. Anybody any questions, you can hang on. Hey, I think you can discuss these slots in the Telegram channel, guys. So why you got to flood this here with slot 1, slot 2? Why don't you put it out there? Then we can make that analysis as well out of whatever the students there. How many slot 1, slot 2, we can get it, that kind of, we can do it there, right? Okay, no questions on this. Yeah. Okay, all right. So then I will close the discussion out here. And anybody watching this offline as well, you can leave the comments after this. I will see you guys tomorrow night. Yeah, okay, all right. Good night to all of you. See you guys in the next lecture. That's tomorrow night at 10ish. Stay blessed. Keep doing it. Yeah. Yes, Keval, we'll do that on Monday. We'll do it on Monday. Yeah.